for the final third video of chapter 4. Oops, as I also in the frame. And we're going to wrap this one up. Luckily, this is one of the more complicated sections, but also the one that we're not going to stress about as much. So pros and cons, pros and cons.
The good thing is you use this every day, and now you know how it works. So if anyone asks you a question, you know the answer to that.
Yes. So with broadcasting, this is pretty much where we transmit these charged particles and waves out into the universe, and how we use them with antennas and other communication devices. That way we get the signals that we hear and enjoy through our cell phones or through our radios, GPSs, anything like that. So this is pretty much what this section is going to cover, just kind of in one slide as an overview.
You'll notice the rainbow. That always tells us something, that we have different radio frequencies assigned for different uses. This is to prevent the interference. Obviously, you don't want to be having the police having to come pick you up when you're just wanting to go somewhere that a taxi could take you.
Yeah, my favorite example is you don't want to be panicked and in the middle of calling 911, and then you get, welcome to CRV 123, you are our 9th caller, and you're like, I just need an ambulance. That's the name of the song. You are no, you want your ambulance. You don't want their lifetime supply of corn. So there's definitely a need to have these different frequencies.
And if you're a police officer, you definitely don't want to have to listen to things that aren't important to you at the given time.
And same things, like if anyone's had the lovely experience of accidentally calling a fax machine instead of someone's phone, you get that wonderful ear-splitting noise that you can't unhear for a while. So we have all these different wavelengths, literally all these different colors, these different squares, blocks. They are specially assigned wavelengths.
Yes, now don't worry about knowing all of this for the test. You can actually just abbreviate each little box. You don't have to write the whole word.
Your test is harder than mine then.
Just kidding. Next, we're going to talk about how cell phones work. All of you have them, and it's just a magic device that you can just push a number, and wow, you can talk to anyone virtually all over the world.
But there's science behind it. There's important things, not just magic, although it can seem like magic sometimes.
So what happens with this call? When I dial a number, it is going to send out a microwave tagged with your unique phone number or someone's unique phone number, and it is going to a tower. You may have seen on movies where someone's in the middle of nowhere and they're searching for the tower.
Oh, you've been that poor desperate person searching for a signal somewhere?
Yes. Hopefully the microwave will go to that tower, and then
it's going to be picked up by a central hub. So if for whatever reason there's a test question that asks you the order this happened, that should make a whole lot of sense. We have an outgoing call, pings the tower, then it comes to a central, which means in the middle hub, so it can then ping another tower and then go to the receiving phone. It's almost like it's a pattern.
And I'm going to show you how fast this works. I surely have your phone number.
I would hope so. I'd be a little hurt if you don't.
I have it under your maiden name. Sorry. Okay.
Sad day.
Here we go. And I want to push call. 1001,
4,
1002.
3. There it is.
Wow.
And I'm going to kind of sort of ignore you a little.
Very quick. Yes. So in that amount of time, of course, these electromagnetic waves are traveling how fast?
At the speed of light.
So these microwaves went to the tower, to the hub, back to a tower, and over to the receiving phone. Hopefully you'll know that order on the test.
If it just so happened to be a question.
Yes.
Just saying. There's going to be a tower, pings the central hub. Your call wasn't ignored, and someone answers it.
Sometimes your call may drop. Sometimes that's because it's going from one tower to a closer tower.
Different central hub.
Yes, I've noticed when I drive back from Chattanooga, and I'll have to call back, or the person will call back. But that's why.
Satellites are another huge instrument that we use in order to manipulate waves and allow us to communicate or send signals. So with satellite communication, these are going to be located outside of our atmosphere, but still trapped within Earth's gravitational pull, which is what allows them to be a satellite and orbit around us. Now, some satellites are stationary, some will move, but we won't worry about that in this chapter. Actually, we probably won't worry about that in any chapter. But these radio waves are typically sent to satellites, and they are going to end up receiving them. Oddly enough, satellite phones use radio waves instead of microwaves like your cell phone uses. And these can be used anywhere in the world.
These would be great for the military or a scientist maybe out at an outpost somewhere or in like a rainforest. Maybe you're down in a valley somewhere and you're really hiding somewhere. At least you can get out with the sat phone. They call it a sat phone a lot of times.
Yes, and they are actually quite expensive to use. They are interesting, but only used in very special circumstances. You're basically seeing your same thing. It transmits it to its receiving signal. Sometimes these are scrambled, sometimes they're not. They scramble them. But pretty basic purpose of most of this section.
Okay, then the satellites are not only used for communicating as a phone call or something like that, they're also used for TV systems. And those satellites have changed a lot just and in your parents' lifetime.
Yes, they're not quite as close to adjust a satellite dish or having their show or something knocked out because the weather was terrible, or because the wind was blowing it and it interfered with your signal.
And just like telephones have gotten much smaller, the satellites, the old satellites, you may have seen some laying around, but they're huge. They're almost the size of a trampoline, some of them were, that would sit out. And then they got smaller and smaller. But
now they're almost cute and unnoticeable compared to the huge ones they used to be.
So those are the weird things that are attached to your house or that weird pole out in your yard that you're not sure of. That's where a lot of those were.
Yeah, because a lot of times, even if you don't use Dish anymore, they won't come and collect it, oddly, the equipment and everything sitting there. But they're pretty much used to, like I mentioned with the phones, there's a decoding box to unscramble those signals, and they are used worldwide to transmit and relay information. Biggest one that you are going to be familiar with is on our next slide with the GPS. And hopefully, if you didn't know before, GPS actually means something besides I'm lost and help me. It stands for Global Positioning System.
And this has a rainbow beside it, so I'm really paying attention to that.
I hope.
Yes.
But they are 24 satellites, and these are used worldwide. Anything like Google Earth is going to be using GPS. The little ones in your phone and in your car, they're using the exact same 24 satellites to broadcast these radio signals. Again, remember, when you're dealing with satellites, you're dealing with radio signals, not microwave signals. That one's strictly for your cell phone. But they are going to be transmitting them anywhere to tell you your precise location on Earth, which is amazing and borderline almost frightening how exact and precise they are at any given moment, any given time. And you're going to need how many of those to find yourself?
Well, like if you're looking for the focus of an earthquake, you need at least 3 seismographs to tell you where it is. So 3 satellites, but you need a 4th one to tell how far above Earth's surface you are. Are you underground? Are you up in the air? Or whatever, that 4th satellite. So 4 will tell you exactly where you are. And right now on your location, to allow your location, automatically those 4 satellites are very, very accurate in pinpointing where you are.
And this is used by military, many companies.
And mom and dad.
And some apps, just like those that'll have tracking devices on your phone, they're using the same satellites. So they are very well taken care of and very much needed. I can't imagine what would happen or how quickly they would be mending one if something were to happen to it. So again, you can just see same kind of pattern of events. There's an source being emitted from somewhere. These 4 satellites are going to find your exact location, ping it, and it will eventually get back to you.
And how fast do these travel?
Again, radio waves and all the electromagnetic spectrum, while it's in a vacuum in space, will travel at the speed of light. But when it hits a medium, their speed differs.
Thank you so much. That's the last
You've reached the end. I know it's heartbreaking. You may have to go back and rewatch them just for the memories and the tears and emotions. It's been a roller coaster. But in all seriousness, we really do miss you guys, and we hope that these have helped you at least a little bit.
Bye-bye.
Bye.